Well, rather than straight up looking what happens to the entire function, I'd like to have a look at what happens to individual points and plot a few of those main points as my method of answering this question. So let me write down, they've given us y equals f of x, some original function, and they've told us that the transform function is y dashed equals 2f of minus x dashed plus 1. I say dashed, I could be saying prime. It's the image point. All right, so I want to rearrange this second equation so it just has a plain old function on the right-hand side. So I need to get rid of that plus 1 and the 2. So I need to do a bit of rearranging here. So I'm going to say y prime minus 1 divided by 2 equals f of minus x prime. So now I have just a plain function on the right hand side of my original and a plain function on the right hand side of my transformed graph. So I can say that this y here has become this, and I can say separately that this x in here has become this minus x over here, which means that I can go ahead now and write that out. Y is equal to y prime minus 1 over 2, and x is equal to minus x prime. Now rearranging, 2y equals y prime minus 1, so 2y plus 1 equals y prime. That's important. And here, x prime is equal to minus x. What have I just found by doing that? I've found that every point x, y on the original graph has become the point, normally you say it turns into x prime, y prime, the image point. So here then, instead of x prime, we write minus x, and instead of y prime, over here we've worked out that it's 2y plus 1. So I'm saying for each point you can go x, y, whatever the point is, on the graph that's drawn above, should become minus x, in other words, reflected in the y-axis, and 2y plus 1. So you need to double the distance away from the x-axis and then go up 1 unit. So let's take this point, for example, reflecting it in the y-axis, not a problem, just stays where it is. Now we need to double its distance from the x-axis and go up 1. So double its distance gets it to there and up 1, and it's now plotted right there. So the crosses are going to be my new graph. Let's go to this point out here. This point here, first of all, you want to go minus x. So you want to take it and put it over here. Next, you want to double its distance from the y-axis, so down here, but then add on 1. So you end up there. Okay, the next one, next point, let's take this one here. We want to reflect it in the y-axis, so here. Then you want to double its distance, it's 2.5, right? So take it down to 5, minus 5. Double its distance from the x-axis, but plus on 1. So it will be there. Okay, so then this point here, minus x gets it over to here. Whoops. Gets it over to that point there. And then we want to double its distance from the x-axis, which is just where it is because it's no distance from the x-axis, and we need to add on 1. So we end up there. This point here, we reflect it across to 4. there, double its distance from the x-axis, which is here, and add on 1, and we end up back here. And so we've taken many of those key points on the original graph. What about this one here? Reflected across so that it's at 3 right there. Double its distance, so it goes down to 3 because 1.5 times 2, and add 1, and it ends up there. And this point right here was out at -4, so it'd go, oh, that's where it's ended up. So now we can actually draw a picture of what happened there for that graph, and we just need to join those points up in the order that they were given. So remember this point here that was out here at 5 -1, right? It became out here, and then we doubled its distance and went back. So it's transformed to here. Now the next point that's next to it is up there, so that's going to join up to there. And then we can see that the next will join down to there. And we'll join up to there, we'll join to there, and we'll join to there. So that would be a picture of what has happened under that transformation, just by looking at how a point on the original graph maps to a point on the transformed graph, and doing that for each point carefully, we can join them up and work that out.